For section 5, we are going to go through writing and graphing two variable inequalities. In this first example, Megan has 100 millimeters of water for the baby garden plants. The tomato plants need 20 millimeters of water each day, and the basil plants need 10 millimeters of water each day. Write an inequality to represent how many of each type of plant she can water today. So, first of all, the very most important thing that you need to do is to define your variables. We want to be specific, so we don't want to just say tomato or basil, but we want to say X is the number of tomato plants, or Y is the number of basil plants. So we don't just want to say, again, generic tomato, but we want to say it's the number of those plants. And that way the directions are more specific, or when your variables are more specific, it makes the inequality easier to understand and even write. And so each tomato plant needs 20, so we would want to say 20 times X plus 10 times B, which I have a little typo there. I changed it not to be B, but the variable Y. And so then when we are looking for the, or now that we have this written, we're ready to graph. And so when we go to graph the inequality, because this is in standard form, the way that we've been talking about graphing would be using intercepts. So intercept is where we cross the x-axis or the y-axis. So if I have 0 basil plants, okay, then I would be finding how many tomato plants I could plant. So that would be in this example over here. 0 of those basil plants, 20 tomato plants. So when I plug in 0, that term cancels out, and so we'd be left with, let me grab my pen tool here again. We would be left with 20 x equals 100. Divide both sides by 20. If we had 0 basil, we could have 5 total tomato plants get watered. Where if I do 0 tomato plants, how many basil plants could I have? And so that part cancels out. We're left with 10y equals 100. And we then can see that we could water 10 basil plants if we watered 0 tomato plants. So with this being the x and the y axis, we can go ahead and graph those intercepts. So over to 5 on the x-axis, up to 10 on the y-axis, and it's less than or equal to, so we'll use that solid line. Use my line tool here. Go ahead and graph that in. And remember that this is just a boundary because of this intercept or this inequality sign. We can have any of these combinations below that would also work. So we can have all combinations in this area. Any combinations above this boundary line we would not have enough water for this scenario. Let's go ahead and look at example number 2. In example number 2, Tom has is going to make chocolate ice cream sundaes and chocolate milkshakes. The sundaes require 3 tablespoons of chocolate, where the milkshakes require 5 tablespoons of chocolate. Write an inequality to represent how many milkshakes and sundaes Tom could make if he had a total of 45 tablespoons of chocolate. And then we're going to graph that inequality afterwards. So again, that number one thing you want to do is to identify some variables. So x is the number of milkshakes and y is the number, x is the number of sundaes, y is the number of milkshakes. Looking through at what our inequality would look like, with the sundaes needing 3 tablespoons of chocolate, we could say 3 times x. Oh, there's my typo again with that letter B. Let's go ahead and update that. And the milkshakes need 5 tablespoons of chocolate. Let's change that to a Y. We could have then several different combinations, having 45 total tablespoons of chocolate. So earlier I showed how to plug in 0. So our idea here is if I do only sundaes, okay, that would have 0 milkshakes. I would have 3x equals 45. Divide both sides by 3, and we would have 15 total sundaes. Or I could have 0 sundaes and be plugging in the, again, 0 for x, solve for y, divide both sides by 5. I could have 8 milkshakes if I had 0 sundaes. So graphing that, the x-axis all the way over to 15 for my intercept, and for my y-intercept up at 8. And again, this is a boundary line for an inequality. So we're going to extend our straight line through here. Didn't quite get all the way down to the axis before it cut off here. Let's see if I can move that a little bit. Here we go, I have to grab the endpoints. And so again, I need to ask myself, this is a boundary line, so are all the possibilities above or below? Well, if I made 0 of each of them, 0 plus 0 is less than 45, or if I made 2 of each of them, these are all of my combinations that do work, so you shade the side that does work on the boundary line, whereas anything up here would not work. Like I can't make 10 of these because I don't have enough chocolate. So again, that is 2 examples of taking a word problem and creating an inequality and graphing.